Welcome back. Welcome back. We are continuing with our lesson under electric circuit. In part one, as I've said, we were laying the foundation. We were learning things that will help us when answering exam question. Today, I've brought one here that I want us to look at. So everything that we have done yesterday will be useful when answering a question like this. Let's look at it. A battery of M 2,4V and negligible internal resistance is connected in a circuit as shown below. A current of 0,8A registers on ammeter A1. This is ammeter A1. And then questions follow. Before answering all these questions, as I've said yesterday, one must first analyze the diagram, especially looking at how the current is moving. Positive, negative, positive, negative. The current is moving from positive to negative. This current is leaving the power source. We don't know the value of the current. As it reaches this point, it won't go through V because of the high resistance of the voltmeter. It will proceed to this point. That's where it will split. More current will go through 3 ohm because there's less resistance here. And then less current will go through 6 ohm because there is more resistance. The current that had gone through 3 ohm and the current that had gone through 6 ohm, they will again combine here. Remember, we've been told to ignore the internal resistance. It means that if it was 4 here, it will be 4 again here. So far, we don't know. The two currents combined here and move to A1. That's where A1 registered 0,8A. This tells us that this current that we're seeing here is the same current that had left the power source. Now we know our total current. The same current will proceed passing the closed circuit, passing 1,0 ohm, then back to the power source. By looking at how the current is moving, we know that 3 ohm and 6 ohm received different current, which tells us that these two resistors are connected in parallel. So if I have to get R parallel here and compare it to 1,0 ohm, the product of R parallel will be in series with 1,0 ohm. Now we know something about how these resistors are connected. Another thing, we know that the total current of the circuit is 0,8A. And we're also given the V battery. Then we can start answering the questions. 4.1, it says, state Ohm's law. The amount of a current through a metal conductor at a constant temperature in a circuit is proportional to the voltage across the conductor. So we know that the relationship between the current and voltage is directly related. Then 4.2, calculate the effective resistance of the circuit. In this one, we are required to calculate the total resistance. So what is it that we already know? We already know that the total current is 0.8A, and then the voltage across the battery is 2.4. Knowing this will enable us to calculate the total resistance. How do we do it? Here's the Ohm's law. I equals to V over R. This is my 4.2. The total current of this circuit is 0.8. V across the battery, I can say total voltage is 2.4. And then we are looking for total resistance, RT. What do we do next? You cross multiply. This is the same as 0.8 over 1. We cross multiply here. 0.8 times RT, 1 times 2.4. This will give me 0.8 RT equals to 2.4. We divide by 0.8, divide by 0.8. Then RT equals to 2.4, 2.4 divided by 0.8. What do we get? We get 3. It's 3 ohms. It means that the effective resistance of this circuit is 3 ohms. 4.3, calculate the reading on 4.3.1, the reading on the voltmeter. Let me bring back this so that we'll see clearly. Calculate the reading on the voltmeter. Where is our voltmeter? This is our voltmeter. And then we are required to calculate the reading there. What do we do? How do we calculate the reading there? I equals to V over R. I, we know it, is 0.8. R, it will be R of this part. Ne? It will be R of this part. We can calculate it. Then, after that, if we have the R parallel and the current which is passing here, it will be easy for us to get the voltage. So let's do it and see what will happen. First, we need R parallel of this part. How do we find R parallel? 1 over R parallel equals to 1 over R1 plus 1 over R2. R1, R2. Or you can say R1, R2. Substitution, 1 over R parallel, 1 over 3 plus 1 over 6. Next step, what do we do? We look at our denominators and see if there is a number where 3 and 6 go and leave no remainder. In this case, it will be 6. How many times does 3 goes into 6? It goes 2 times. Then we say 2 times 1 plus. How many times does 6 goes into 6? It goes 1 times 1. Then you find the sum of the numerators, which will be 3, because it will be 2 plus 1. 3 divided by 6. Remember, we still have 1 over r parallel. What do we do next? Cross multiply. 3 times r parallel equals to 1 times 6. 3 r parallel equals to 6. You divide by 3. Divide by 3. 3 goes how many times into 3? 1. It's r parallel. Ne? How many times does 3 goes into 6? 2. This is 2 ohms. R parallel. What I've just calculated here is R parallel of these 2 resistors. Do I know the current which is passing through 3 ohm and 6 ohm? Yes, I do. This is 0.8. This 0.8 was the same before the split. What is splitting here is current, which is 0.8. So combination of the current which is passing through 3 and 6 is 0.8 A. It means that I know the current which is passing through R parallel. That current is 0.8 A. Now I know that I have my R parallel and the current which is passing through R parallel. It means that now I am in a position to calculate V parallel, voltage of these parallel resistors. V parallel equals to IR. My I is 0.8. And then R parallel, I've just calculated it, is 2 ohm. Then let's use the calculator. 0.8 multiplied by 2. What do we get? 1.6. 1.6 V. This is the voltmeter, which is, or in fact, this is the reading on the voltmeter. It's 1.6 V. 4.3.2. Calculate the reading on the ammeter. Calculate the reading on the ammeter, not just ammeter 2. What is it that they want me to calculate? I'm required to calculate the current which is passing through this 6 ohm. The same current that will go through 6 ohm is the current that will go through A2. Is there any information that I know about 6 ohm? Do I know the voltage of 6 ohm? I know the resistance, I know that it's 6 ohm, but do I know the voltage? Then we go back to our previous lesson and remind ourselves about the voltage of the resistors that are in parallel. We have learned that the voltage of the resistors that are in parallel is the same. The voltage of the resistors that are in parallel is the same. And then we have just calculated the voltage of the parallel resistors. and we found that is 1,6. It means that the voltage of 3 ohm is 1,6, and the voltage of 6 ohm is also 1,6. Now, we are in a position to calculate the current, which is passing through 6 ohm, then through A2. Because here we know the resistor and we also know the voltage. Our formula will be this one, 4,3,2 I equals to V over R. The voltage, I've already said that is 1,6. In place of V, you write 1,6. And then the resistance is 6. Now is 1,6. 1,6 divided by 6. This gives us 0,26 and 6. Yeah, let me write like this: 0,27A. 0,27A. This 0,27A is the current which is passing through 6 ohm. Before we go to the next question, I want us to calculate the current which is passing through 3 ohm. We will not ask this question, I just want us to do it. The current which is passing through 3 ohm resistor, same formula, I equals to V over R. What is the voltage there? The voltage is 1,6. 1,6. 1,6. What is the resistance now? 3. 1,6 divided by 3. 1,6 divided by 3. It gives us 0,53. 0,53A. So I have calculated the current which is going through 6 ohm. For sure it will be recorded at A2. And then I found that is 0,27 this here. And then I've calculated the current which is going through 3 ohm. And then I found that is 0,53. Remember, earlier I've said that this 0,8 is the one that had split here. More current will go through 3 ohm resistor because it has less resistance compared to 6 ohm. So let's see what have we got here. 0,53A is the current which is going through 3 ohm resistor. And then 0,27A is the current which is going through 6 ohm resistor. If you compare the two, 0,53A is bigger than 0,27A. If we add these two here, let me increase the space. If we add these two, we must get the total resistance of the circuit, which is 0,8. Let's do it and see what will happen. 0,27 plus 0,53. This gives us 0,8. Let's move to the next question. The next question requires us to calculate the amount of energy in kilowatt hour that is transferred to the circuit in 48 hours. So I'll take you back to some of the things that we've done in part 1. I want us to look at the formulas that I gave you previously. Remember this formula here, energy, P equals to E over T. Remember this formula here, P equals to V over I. So we are going to make use of this formula. Let me read the question again. Calculate the amount of energy in kilowatt hour that is transferred to the circuit in 48 hours. Remember, our time now, it must be in hours. And then here we're given hours. It means that we are not going to make changes when it comes to time. And then the power will not be in watts. It must be in kilowatts. So how do we answer this question? 4.4. The question requires us to calculate the amount of energy. So you put the formula, energy equals to power times time. Is time given? Yes, time is given. It's 48 hours. Is power given? No, power is not given. It means that we must first know the power in order to use this formula. How do we calculate power? Here's the formula, P equals to V multiplied by I. Is V given? Yes, V is given. It's 2,4. Is I given? Do we know our total current? Yes, our total current of this circuit is 0,8. So what do we get when we multiply the two? 0,8 multiplied by 2,4. 1,92. 1,92 watts. We know that the unit of measurement of power is watts. But remember, we are required to find the amount of energy in kilowatt hour. It means that our power must not be in watts, it must be in kilowatts. And then how do we convert watts to kilowatts? You divide by 1,000. 1,92 divided by 1,000, what are we getting? 0,00192 kilowatts. Remember, our time is 48 hours. We got our power in kilowatts and our time is in 48 hours. Now we can bring this formula here. Watts equals to power times time. Power is 0,00192. The time is 48. What do we get when we multiply the two? 0,00192 multiplied by 48. I'm getting 0,09216 kilowatt hour. We have managed to calculate the amount of energy and it is in the right units, which is kilowatt hour, as we've been asked. 4.5. 4.5. The 3 ohm resistor is now replaced by a 6 ohm resistor. Okay, this 3 ohm resistor is now replaced by 6 ohm resistor. It means that in place of this 3 ohm, we are putting 6. Now we have 6 and 6. How will this affect each of the following? Choose from increases, decreases, or remained the same. Before we answer this question, let's look at what happens here. A current of 0.8 is splitting here. More current will go through 3 ohm, and then less current will go through 6 ohm. More current is will come to this side because there's less resistance. Now the question will be, what will happen if I increase the resistance here? What will happen if I increase the resistance? You increase the resistance this side, more current will come this side. Now I'm increasing the more current was using this path because there's less resistance. Now I've increased it. It means that some of the current will come to use this path here because on this side resistance has been increased. So our question says 3 ohm resistor is now replaced by a 6 ohm resistor. How will this affect each of the following? We're choosing the answers here. How will this affect each of the following? The reading on A1. Explain the answer. The reading on A1. This is my A1 here. What will happen to A1? You increase the resistance of the circuit. The current will decrease. The current will decrease because the resistance of the circuit had been increased. We know that resistance is inversely proportional to current. As you increase the resistance, the current will decrease. Our choice here will be decrease. Reason being that resistance is inversely proportional to current. Then 4.5.2. What will happen to the reading on A2? A2 is this one. You increase the resistance here. Some of the current will follow this path here, which means that we will see an increase in the reading there. We'll see the increase in the current. So the answer will be increase. So that's how you answer a question like this.